This is Design Safe Radio, where natural hazards researchers strive to make our society more resilient to everything nature throws at us.
There's a whole host of kind of experimental testing kind of that's going on, that'll be going on shortly to try to see what the design of niche may need to look like. So for example, there's experiments going on at the University of Miami, I think starting this month, on some aspects of the water. And I'm not involved in that part of the project, so I don't exactly know what's going on, but this is the type of things that are going on in my space. And the reason why I was asked to be on the project is to see if we could potentially simulate some aspects of these non-synoptic winds, like you mentioned, right? So things like thunderstorm winds, things like tornado-like winds. Could we...
Non-synoptic basically means like shorter time scale stuff, like
that's right, shorter time and space.
Hours or days, but seconds, minutes.
Exactly. And so the winds, thunderstorms and tornadoes as events or as storms fall into that space. And so the winds generated from them, generally are over small time and space scales, right? Like a tornado, it doesn't last very long. It happens over a small spatial dimension. And so we need to kind of understand, again, like we talked about earlier, how these events impact structures differently than what we've assumed all these years in wind engineering. And so, they had asked me, hey, can we simulate some aspects of these winds in what amounts to basically a straight line wind tunnel, right? There's specialized tornado simulators that can generate vortices, and things can be studied specifically for those types of facilities. And so that's what on my end we're trying to figure out now. So we're starting, I think next week we'll start to run experiments in the University of Florida boundary layer wind tunnel, right, which is also an Erie facility, to see if we can generate some vortex-like flow through essentially what is a straight line wind tunnel. And some of the computational simulations suggest that we can, but I think we're kind of really looking to the results of the experimental testing to see if it's actually possible. It's not something we can do. Another thing too is like not just a vortex in the tunnel, but also things like wind profiles, how the profiles. So typically in wind engineering, the atmospheric boundary layer, we assume that it increases monotonically with height. The wind speed in things like thunderstorms, tornadoes, that's not the case. A lot of times the highest wind speed is right near the ground, and then it kind of tapers off after that. So the question is, can we try to recreate profiles that look like that in what essentially is a straight line wind tunnel? And so that's another aspect of the investigation that I'm working on, in one aspect of the experimental testing that's going on, in addition to all the other wind and water experiments that we'll look at to help inform the eventual niche design. So, but I'm excited about it. I'm really excited about the team. A lot of expertise in various areas, and really not even from the scientific and technical perspective, which is obviously exciting, but also the potential down the road. If this thing ever gets actually built, all the other potential with a facility like niche, the societal benefits, things like bringing stakeholders in to help us understand which experiments need to be run. Again, for me and for a lot of other people, the goal is really to mitigate the impacts of natural hazards on structures. And, at least this first design phase gives us the opportunity to investigate how to do that.
Yeah, exactly. We just got back from a National Science Foundation conference for research infrastructure, so mid-scale on up. And it was really exciting talking about niche there and thinking about some of the opportunities there and looking at examples of this done really well. Things like the National Magnet Lab that does a great job with outreach and engaging stakeholders and showing how their research affects daily life. But seeing some, thinking about even the existing NARI facilities, but then going into niche, how amazing it's going to be to be able to showcase exactly the research capabilities, but also bring in everyone from high school science class to a senator and show how this work and the work of all the research teams that are going through affect the daily life and mitigating the effects of these extreme events. So it's going to be really cool.
Yeah, I completely agree with you. I honestly, been studying windstorms for a while, but the outreach and impact, the societal impact is, I think, the most important point and it's the hardest to do. We need to be able to reach the public, really to, inform them of the benefits of doing mitigation and the risks that are there. I think that's really a challenging part. And if we don't do that part, a lot of the stuff that we do on the technical side is just, it's ultimately it has very little impact.
Right.
Thanks for listening to today's episode of Design Safe Radio. Be sure to like and subscribe on whatever platform you happen to be listening to this on. It really helps people find our show. Thanks to our amazing sponsors, the National Science Foundation and the NARI Network Coordination Office, which is award number 2129782. Big thank you to Marty LaChance, our guest booker and topic researcher extraordinaire, and Raquel Ruiz, who is our video and audio editor. I'm your host and NARI Facility Scheduling and Operations Coordinator, Dan Zahner. We'll see you in the next episode. Until then, stay resilient.